the blinking LED tutorial for the Slenduino board. Hi folks, and welcome back to creativity/design.tk. Today we are going to start the first session of tutorials based on Slenduino, development board with microchip 12F683 core. For those who haven't read the blog, this board has designed and focused on mobile project, but you can use it anytime you want to implement your project with a low profile energy chip, or you don't need a big MIPS architecture. So, for most information, the chip presents this feature: CPU with 20 MHz clock speed, core size 8-bit, program memory with 3.5 kilobit, RAM memory with 128 byte, EEPROM memory with 256 byte, and some other peripheral as ADC, comparator, PWM, timer, and capacitor touch channel. Jumping to develop, we choose as programming tool the Grid Count Graphical Basic, a free compiler project developed for 8-bit microchip PIC and Atmel AVR microcontrollers. If you prefer others compiler, you can program with it, but in this and future tutorials, we'll refer to the GCGB compiler to simplify the compiling to everyone. This first tutorial, as usual, will be the blinking LED. Okay, when the compiler was opened, we have this graphical view with a category drop-down menu on the left, the subroutine function view on the right, and the icons of our flow code at the center. At beginning, we have to select the program tab and click on hardware setting, type our chip, select the speed of microcontroller and the setting for the internal oscillator. We have many sets, but in this example we are going to work with the internal oscillator setting. So, we have to click over this option. Come back to the icons view to create our program. We click on Input Output and drag and drop pulse out into the code. To change any options, click on select our pin among those variables, for example GPO 0, then select the period time for square wave and the time unit. To compile the program that you can see, select the tools and click to compile. If it's all okay, the compiler will show a new menu command windows just for a second, and you can find the X files at the code directory saved. We wanna want to show one other way to make the same code with a defined duty cycle ratio. Just click on Cancel K to cancel this code and drag and drop two sets from Input-Output list. Now we click on Constant to set up our output pin. We call it Out and we type the kind of GPO just next to. Click OK. Now we have defined our output. Select it on bit and set the state. Now we define the delay time. That's all for now. We remember you to follow us over this channel, on Twitter and over our blog for the next tutorials or next updates.